Okay, so let's continue what we were doing before. Now I know this one seems a lot harder, but it's just a little bit more algebra. We're still going to use the same properties we've been using, so we're still going to use the sum of the angles around a point is equal to 360. We don't have to. We actually can do this entire thing just using vertical angles. Like this and this are vertical angles. We could use the fact that these are vertical angles, so we could set them equal to each other and use substitution a lot of different ways. So I'm going to do a lot of what we do on this one that applies to the rest of them. So there's a lot of methods to do this. So I want to show you several different methods instead of just one. So I think the easiest way is to, if I were to look at these and add them together, I'll realize that my x cancels, so I'll be able to figure out y directly. So that is what I noticed first. Did you notice that first? If not, that's totally fine. Everybody notices different things. So, but we do have a straight line right here, and the sum of the angles around a straight line, or at a straight line, they add up to be 180. So let's just take y plus x, that's this angle, plus this angle, y minus x, that's an equal sign, Mr. Zenos. If you want to put them in parentheses and say that's one angle plus one angle, you can. You don't really need to. But that's going to be equal to 180 degrees because these are the sum of the angles at a straight line. We've been using that the whole time. So let's simplify a little bit. Y plus y is 2y. X plus negative x is 0, so it cancels. So then we divide both sides by 2, and we get y is equal to 90. Interesting. Y is equal to 90. So what's nice about that is that we have that information. So if I want to figure out what x is equal to, I just need to plug it into something with y. So let's look at this. Let's use the exact same thing. We could go this way now. That's also a straight line, so we could say 2x plus, so 2x is this angle, plus this angle, y plus x, equals 180. So simplifying a little bit, 2x plus 1x is 3x, plus y, but we don't have to write y anymore. We know what y is. Let's just write what y is. Subtract 90 from both sides. 3x equals 90. Divide both sides by 3 to get x equals 30. And we can plug this into everything and mess with our properties and see what happens. Okay, maybe you went about this a different way. Maybe you decided to start a different way. There's a lot of ways to do it, so don't get scared. So another way that we could do it we could say that these are vertical angles. So if they're vertical angles, then they're equivalent, they're congruent, they're equal in measure, all that kind of stuff. So this left angle, 2x, is equal to this using the fact that they're vertical angles. So we can just set them equal and then solve. So let's add x to both sides. So y is equal to 3x. Now that's not super helpful because we want a number over here, but it's really helpful because now we can just plug it into anything. Okay? So we can go ahead and say, all right, well, which one do I want to do? Maybe I say, maybe I use, what's the easiest ones? Let's see. Let's do this one. Let's do a sum of angles at a straight line is equal to 180. And I want to use something different. Let's say that these right here, let's just use these two. Let's say 2x, the exact same thing that we would use before, plus y plus x equals 180. And instead of writing y, let's write that the fact that y is equal to 3x. So instead of writing y, we can now write 3x to only have one variable. If you remember from last year and in 8th grade, this is kind of like how we would go about solving a system of equations in kind of a more ad hoc way. But this is just substitution. We figured out how y relates to x, so we can substitute something to do with x, so we only have one variable. You can't solve an equation with two variables unless you have two equations. So 2x plus 3x is 5x, plus one more x is 6x. Divide by 6, and you get x equals 30. Hey, we already knew that. So you see, it should give you the exact same results regardless. Now, since y is equal to 3x, and x is equal to 30, y is equal to 3 times 30 is 90. Hey! But do you see how there's a lot of ways you could do it? You could set up a whole system of equations if that's your bag. You could say one equation is that these are equal. So 2x equals y minus x. If you want, you could get it into standard form to get 3x equals y, and then subtract y to get 3x minus y equals 0. So that's your first equation in standard form. If you want to have a reminder of how systems work, these are vertical angles. And if you set them equal, you'll get 0 equals 0 once you solve. So we don't really want to use those, but we could get another equation from anywhere, like anywhere really. We can get an equation from right here, adding these up. Y plus x plus y minus x equals 180. But in this case, you know, it's not going to end up being much of a system because you'll have like y equals 90 from this because we've already solved this. And you technically do have a system. You're just gonna you know what y is, and so when you're trying to solve it, you just substitute. But there's so many ways to do it, so don't get super trapped in thinking that there's only one way. So this one's the same idea. I feel like using vertical angles on this one's good. So notice you have the line CD. This is one of those cases that I mentioned before about how it's kind of hard to see which ones are vertical angles. So here's how we look at these. Let's go ahead and try to do this. There we go. Straighten it up. So x is the angle formed at the intersection of the line CD and EF. So that's that angle. Hopefully you guys agree that this angle right here is formed from CD intersecting with EF. Now, the vertical angle for this one will be the other angle that's formed on the opposite side. That's how you know which ones are vertical angles. So just kind of like highlight the lines themselves and see that it's going to be all the angles formed by that intersection. So this and that. That's why they call them vertical angles. So they're just the ones that are across from each other, formed by the exact same two lines. So just kind of like filter out all the rest of the noise. You don't care about AB when it comes to vertical angles formed by CD and EF, like I have written right here. But either way, we know that this is also going to be X. That's the important takeaway from that part. And then, so we can actually still use more vertical angles. So if I look at this and I draw a line like that, the angles formed from the intersection of AB and EF, because that's the only other angle we have information about. So that means that these two in cyan, this angle 4x minus 10 is the same as this angle 4x minus 10 because they're vertical angles, because that's the same angle formed by the lines intersecting of AB and EF. Those two lines intersect, and that means that no matter how you draw it, these two angles have to be equivalent. And honestly, if you were to take two sticks and cross them at each other, and then and no matter how you move it, you'll realize that those angles move together as and they stay the same. So what's nice about this is we can use something called complementary angles. Now you can still use supplementary angles in this case, but notice this right here forms a 90-degree angle, which means that this one right here has to be a 90-degree angle, because the only way for these two to exist, I know that this one's split into two angles, but this whole thing has to be 90 degrees for the exact same reason, because if you were to go from here to there, you've got to equal 180 degrees. So when you subtract 90 from 180, you get 90. Or you can realize that this right here is a complementary angle. The sum of these two angles must be 90 degrees. The sum of two angles, in this case, equals 90 degrees. And again, you know, we don't really have proof that this whole thing is equal to 90 degrees. So if we want to prove it, we'd have to say that the sum of all of these angles equals 180 degrees, because those are supplementary. But since this is a 90-degree angle right here, when we subtract that 90 degrees, we are guaranteed that this is also 90 degrees. And again, there's a lot of ways to do this. You can just write it directly straight out and say that x plus 4x minus 10 plus 90 degrees. That's all of these angles. This is the 90-degree angle. This is the 4x minus 10, and this is the x. That's where I'm getting all my stuff. And that, in this case, we're using the supplementary property. So simplifying a little bit, we get x plus 4x is 5x. Negative 10 plus 90 is going to be positive 80. Subtract 80. 5x equals 100. Divide both sides by 5. And we get x equals 20. So x is 20 degrees. And that's all they asked us for. But we can go through and confirm this with a lot of different things. So in this case, we weren't really guaranteed that it was 90 degrees, except we were. Logically, you know, like when you just analyze what you're looking at, you have a straight line. If all of these angles add up to be 180, and this one is 90, then this one has to be 90. Because if one of the angles is 90 degrees, and the other half has to be 90 degrees. This one's the same thing. Now, we could just go through and say, all right, well, these are vertical angles. And again, the way I know that is that it's the intersection of these two lines, which means that this and this have to be congruent, because and again, take some sticks, cross them over each other. Watch what happens when you change one of the angles. You can't change one of the angles without changing the other one without breaking the stick. So these are going to be equivalent, so I could just write x minus 10 right here. And by that same logic, these two lines mean that these two are equivalent. And we like to use symbols like that to say which ones are congruent. So that's just one thing that I'm going to kind of start doing a little bit more here. So that means that this one has to be x minus 11. So what's nice about this is the fact that going from all the way around this thing, I'm going to use a different color for y'all. So to go from here to there, all of those angles at a straight line must add together to be 180. Same thing. Notice we're using the same exact logic over and over again. Let me color code this for you because I have enough colors. So let's do x minus 11 plus 3x plus 6. It's this one right here. Plus x minus 10 equals 180. And then x plus 3x is 4x plus x is 5x. Negative 11 plus 6 is negative 5, minus 10 is negative 15. Add 15 to both sides to get 5x equals 195. Divide both sides by 5. To get x must be equal to, goes in there 3 times 39 degrees. Oh wait, y'all do that arithmetic to confirm my numbers. So we figured out x. We still have a little bit of a problem with y. So let's look at this. Let's say, all right, well, this angle right here, this is a vertical angle with this one. And again, it's because this line intersects with this line. And these two angles, I'm going to use 3 of these to kind of represent them as different ones. We like to do that. So those must be equal. So y is equal to 3x plus 6. They are vertical angles. But we know what x is. Y is equal to 3 times 39 plus 6. So 3 times 39 is 90 plus 27 is 117. Plus 6 equals 123. Now, my question for you is, did you find a better way to do this? Did you find a faster way, a more efficient way, one that makes more sense in your head? Tell us about it. Same idea here. So, one thing, it's often easiest to find out your vertical angles first. So, this is a vertical angle with that. So that means that this over here is 3/4 x minus 2. So to figure out all of this, we can easily just go like, all right, well, that's got y and x in it, so I might want to hold off on that part. But we know this is 90 because we've got this symbol right here. So honestly, this one's a little bit rough because it's got fractions, so bear with me. So it's a little bit of a fraction review going on now. So let's look at this. We could use a vertical angle with this and this, set them equal, have 2 equations, kind of give ourselves a little system of equation practice. But maybe we just kind of add all of these together. The fractions are going to be the hard part. 3/4 x minus 2 is this angle. Plus 90 is this angle. Plus 2/5 x is this angle. And that's all going to add together to be 180 degrees. Or you can just say these two added together will be 90 because but that'll come from the equation as well. So 3/4 x, negative 2 plus 90 is positive 88 plus 2/5 x. So we can do one of 2 things here. We can either get the same denominator so that we can combine our like terms, but we can't do that. We can't add 2 fractions without getting the same denominator. Or we can just get that 88 to the other side and then just fix one denominator at a time. It's up to you. There's a lot of ways to do it. I'm going to show you how to do both ways just to get a reminder on that. So let me just kind of get my stuff with x on one side and my numbers on the other side. And if you say your brain hurts on this one, it just means we need a little bit of practice. That's all. Just need a little bit of practice on some of this. So this right here, so it should be 92 degrees, I feel. If I make a mistake, please tell me. So maybe we do this in a couple of different ways. Maybe we look at this and let's do it the way that you guys probably learned first. So I want this denominator and this denominator to match, because I can't combine like terms unless they do. I can't add those 2 coefficients unless they do. So one way to do it We don't want to change the value. So I need to figure out my target one. So I'm going to look at the, I'm going to look at this and this, and I'm going to say I want it to be 20 because 4 times 5 is 20. So if this denominator was 20, I could add them. So the only way I know how to do this without changing my values is I can multiply this by 5 over 5. I can do this because 5 over 5 is equal to 1. And on this term, if I don't want to change it, but I want to change its form, I can only multiply by 1, an alternate form of 1. So to get that denominator to be 20, I have to multiply the top and the bottom by 4 on both of these. So this is really 15 over 20. If you want to throw this into a calculator to confirm that 15 over 20 is the exact same thing as 3 over 4, you can. And this one is 8 over 20. So 15 over 20 plus x over 20. If I combine like terms, I have to add my coefficients. So I can do that now because my denominator is the same. Now I just add my numerators. 15 plus 8 is 23. And if you need to, go on to Khan Academy and review how to add two fractions with different denominators. So we could either multiply both sides here by the reciprocal, that works, or we can multiply both sides by 20. You can do a two-step process to get 23x equals, you could work 92 times 20, get a number, and then divide it by 23 once you get this thing off of there, and go through that whole process. If you want to throw this stuff into a calculator and just do the steps that way, go ahead. But me, personally, I really like to represent 92. Maybe you've realized that it is 23 times, is it 23 times 3? 23 times 4? 23 times 4. Go put this into a calculator, confirm if it's the exact same thing. 20 times 4 is 80, plus 3 times 4 is 12. 80 plus 12 is 92. Now, when I divide both sides by 23, I don't actually have, I didn't need to actually calculate anything. I just get to do double cross out. 4 times 20 is 80. Were there a lot of different ways to do this? Absolutely. Yes. Maybe we don't fix our denominators like that. Maybe instead, we go ahead and say, and fix them one at a time. Maybe we just say, I don't like this 4 denominator, so I'm going to multiply both sides of my equation by 4. When this distributes onto both of those, I get 4 times 3 over 4 is just 3. And my x is still there. 4 times 2/5 is 8/5. It just hits the numerator. It's a little invisible over 1 right there. I'm going to leave this as 92 times 4. Why do extra work? I don't like this 5 right here, so I'm going to multiply both sides of my equation by 5. When I distribute this, I get 15x. 5 times 8 over 5x. The 5's cancel. This cancels with that when it hits that term. And I just get plus 8x. And I haven't messed with that yet. I'm just kind of leaving it over there. But this is 23x equals 92 times 4 times 5. So 92 times 20. So, but again, I could break this up. You know, if you want to throw this into a calculator, that's fine. If I realize that 92 is 23 times 4, that all works. It's all great because I can still do it the exact same way. Your calculator can also give you this answer. 4 times 4 is 16 times 5 is 80. Doesn't really matter what you did. You're going to get 80 as your measure for x. Now, when we want to figure out y, we just need to do this plus that equals 180 and then plug our numbers in. So y plus 3 over 4x minus 2 equals 180. So y plus 3/4 times 80, because I'm just replacing x with what it's equal to. So y, so 3/4 times 80, 3 times 180 is 240, divided by 4 is 60. Or you can just break it up a little bit more, and you can cancel a 4 in this to get a 20. Either way you want to do it. Let me just confirm. If I cancel a 4 right here, I get a 20 right there. 3 times 20 is 60. So we haven't figured out what y is yet, but we've got y plus 60 minus 2 equals 180. Y plus 58 equals 180. Subtract 58. And I'm getting tired, so if I make a goof here, you gotta have to tell me. So it should be like 122, I feel like that's right. I feel like 122 is right. My brain's starting to move slower. Feel like it's 122. If I goof up, the logic's there. I just might be too tired to continue doing some of the arithmetics. Doing it all day. I need more space for some of this. Kind of want to keep this here for right now, just so it looks nice. And what's nice is we'll do this for all the rest of them. The rest of them don't have fractions, so they're actually easier. So again, I do, this one's easy. So these are vertical angles because it's the angle that's formed right there. So that's also y. So I can go ahead and actually figure out what y is by doing 68 plus y equals 180. Subtract 68. To get y equals 180 minus 68 is like 112, I think. Yep, should be. So I've already got y. And that was using, and if they ask you about the properties specifically, that was using that the sum of angles at a straight line is equal to 180. It's like a broken record over here. Now, a couple ways to do this next one to find x is, there's a lot of ways to do it, but you can also use the sum of angles. Just gonna keep saying this. The sum of angles at a straight line is equal to 180 degrees, and you'll get y plus 4x minus 2 is that other angle, plus 30 equals 180. And let's simplify a little bit and replace y with what it's equal to. So instead of writing y, I'll write 112. (112) minus 2 is 110, plus 30 is 140. I combined these terms. That's how I got all that. And then plus the 4x equals 180. Subtract 140 from both sides to get 4x equals 180 minus 140 is 40. Divide both sides by 4, and you get x equals 10. And you've filled out all your stuff in the best way possible. And you're able to tell people that you have used the sum of angles at a straight line is equal to 180 degrees so many times. And it's going to be really hard to forget as you keep using it. Let's look at our vertical angles. 2x minus plus 1, because this line, and this line intersect, and their vertical angles are the same. This is also vertical angles over here. This is forming a 90-degree angle, so we can start off with our complementary angle stuff, kind of mix it up a little bit. We could add all of these together and say it's equal to 180. Actually, we can't guarantee that that's 90 degrees, so ignore that. We don't actually have the 90-degree symbol. So let's go ahead and add all these together and equal 180. 8 over 9x plus 10 plus 2x plus 1, that's this one right here, plus 3x plus 10, that's this one right here. May or may not be 90. It might just look like it's 90. And I almost fell into that trap. So notice we only have x's, we don't have y's here, so it means we're going to actually be able to solve this. So let's simplify a little bit just to kind of make it look nicer. Let's leave this as 8 over 9x. 10 plus 1, let me put plus 5x. I want to simplify it as much as possible. That's me combining those. Plus 10 plus 1 is 11, plus 10 is 21. Now, if I want to have the same denominator, I can go through the whole process of getting the same denominators, but 5x is the same thing as 45x over 9. And we can basically say that this is 5 over 1, multiply the top and the bottom by 9 to figure that out, to get 45 over 9. Another way we can do it is just to multiply everything by 9. Let me kind of subtract this 21 first. So 159. Maybe I multiply both sides by 9. Maybe I like that way of doing it more. Doesn't really matter what you do, but when this distributes onto both of those, I get 8x when that 9 cancels with that. And then when it distributes onto this, I get plus 45x. I'll do my calculations at the end. 8x plus 45x is a solid 53x. And then now maybe I see if one of these things is divisible by 53, because I'm going to have to divide by 53 at some point. And if you use your calculator to make this easier, I'm with you. But 59 is, what's funny about 159 is 159 is equal to 53, which is the number we're trying to divide by, times 3. So I can rewrite that 159 as 53 times 3. Just so I can do this. It looks nicer, and often these things are going to be something like that. You know, maybe it will be, maybe it won't be. Just remember, the option to throw it into a calculator is always there. These are just some nice mental math tricks to make things a little bit easier to understand our number sense. But either way, x is 27. Now I really just need to kind of do another thing and then plug it in, and that works. So let's. Is there a way to choose something that doesn't have a bunch of fractions showing up? And kind of use some of this space over here. Let's try. What is the easiest one? There's a bunch of lines here, a bunch of straight lines, which means we have a bunch of things that we can add up to be 180. I feel like this one may or may not be easiest. We don't really have to deal with the fraction that much now that we know what x is. So let's get 8 over 9x plus 10 for this angle, and then plus y minus 3. We need something with y in it. That's why we're having to go over to these angles. Plus another y right here, plus 2x plus 1 for this part. All of the angles right here need to add together to be 180. So let's plug in our x now, because it's going to fix and make this a little nicer. So 8 over 9 times 27. Our plus 10 is still there. Our plus y. Hold up. Let me back up. Let me simplify a little bit more first. So I replaced x with 27. 10 minus 3 is 7. Plus 1 is 8. Maybe we do that a little bit. So I'm just underlining the things that I've already written. I've written my 8 over 9x, but instead of writing x, I wrote 27. I've combined my numbers, my constants, a little bit, just to make it look a little bit nicer. 10 minus 3 is 7, plus 1 is 8. I still have my 2x right here. So 2 times 27 is 54. Because I'm replacing x everywhere I saw x with 27 now. Because I know what it is. It's right there. Plus y is 2y. I know this looks crazy, but you guys can simplify it in a lot of other ways too. So 8 times 27 over 9. A 9 cancels in here and here. So that 27 is 9 times 3, so I can just cancel a 9. Regardless, it's going to become 24. (24) plus 8 is 32. Plus 54 is going to be 86. 86, I believe. 24 plus 8 is 32. Plus 54 is 86. Should be. Subtract 86 from both sides to get 2y equals 180 minus 86 is going to be 94, I believe. 10 minus 6 is 4. 17 minus 8 is 9. Divide both sides by 2 to get y equals 94 over 2 is a number of some sort. It's going to be 47. If you find a more efficient way to go through this, please tell me. There's a lot of little efficient methods to do with these things. So I've got straight angle. 2 rays with the same vertex are distinct and collinear. Then the rays form a line called a straight angle. Yes. Let's look at the other part. And then vertical angles, we've talked about it over and over again. So here's the problem set. I'm not going to work these out right now. Go ahead and work them out, and you can ask questions in office hours. And you can always send me or Ms. Tragle an email, and we'll help you out.